Question 19 is a very long question, but it's really good practice for the exam. It says below is a heating curve and constant table for water. So all of those constants are provided. And you are starting with 25 grams of water. So our mass is 25 grams. Part A, how much energy is required for water to vaporize at 100 degrees Celsius? So essentially we're just looking for how much energy it takes to do that. That's just going to be Q, our energy, is equal to N times delta H of vaporization. If they ask you or they give you anything in moles, that N is why it's important, but we have grams, so I'm going to change that to M for mass. So Q is equal to 25 grams times the delta H of vaporization, 2,257 joules per gram. Those grams cancel, and Q is equal to 56425 joules. Part B says, what is the temperature at fusion? Fusion is just a more scientific word for melting. So what temperature does ice melt? And that's just going to be 0 degrees Celsius. So just use the table to answer that, or just know that ice melts at 0 degrees. Part C, what is the energy required to heat water from 20 degrees Celsius to 80 degrees Celsius? The good news with that is that it's within one phase change, so essentially you only need to use one equation. And since it's in a phase, we're going to have to use the Q is equal to MCAT, since there is that change in temperature. Our mass is 25 grams. Our specific heat, or lowercase c, as a liquid, since 20 to 80 degrees Celsius in liquid phase, is 4.184. And our change in temperature is 80 degrees Celsius minus 20 degrees Celsius. So those degrees Celsius will cancel, the grams will be canceled, and we'll be left with joules. So Q is equal to 6276 joules. Part D says, what is the total energy required to heat water from negative 12 degrees all the way to 135 degrees? So notice there is a lot going on between then, so we need to actually have several different calculations and then add them up. First, we need to know what is the temperature or the energy required to go from solid to liquid. So that's going to be from negative 12 degrees to 0 degrees, and I'm going to label that Q1. And then I need to know how much energy is required to go from a solid to a liquid, Q2. How much energy is required to go from 0 degrees to 100 degrees when it's a liquid, Q3. And then how much energy is required for it to be vaporized, Q4. That's the same thing as question A. So we already answered question A, so we don't have to do any extra math there. And then going from 100 degrees Celsius to 135 is Q5. So when everything's said and done, we need to calculate the Q total, and that's just Q1 plus Q2 plus Q3 plus Q4 plus Q5. Let's get started. Q1 is when we're going from negative 12 degrees Celsius to 0 degrees Celsius when it's in the solid phase. So we have to use Q equals MCAT, 25 grams times the specific heat of solid water, times change in temperature, which is just 12 degrees. And so I get 626 joules. Q2, since this is a transition in phase changes, I have to use M times delta H of fusion. Since we're trying to overcome this horizontal line, just represents that phase change. 25 grams times delta H of fusion is 333. And I get 8,340 joules. Q3 is when we're going from 0 to 100 degrees Celsius. So we need to use MCAT when it's in the liquid phase. So that's going to be 25 grams times 4.1 times 100 minus 0, which is 100. So Q3 is equal to 10,460. Q4, we did it in A, so Q4 is just equal to 56,425 joules. Q5 is when we're going from 100 degrees Celsius to 135. So Q5 is equal to MCAT in the gas phase, so that's 2 joules per grams to C. And for Q5, I get 1750 joules. So now I just have to add everything up. The Q total, the energy required to do all of that, is equal to 626. And it's important to make sure all of your units are consistent, so make sure you don't have kilojoules and joules, make sure they're all the same. So I get 77,601 joules, or just 77 or 78 if you round up kilojoules.